Internet Protocol address is an address assigned to each device connected to a computer network. There are two IP versions, IPv4 and IPv6. IPv4 address is a 32-bit address and IPv6 address is a 128-bit address. Therefore, we can have 2 to the power 32 addresses for IPv4 and we can have 2 to the power 128 addresses for IPv6. IP address assigned to each device in a network is unique. Dotted decimal and binary notation. In dotted decimal notation, IP address is divided into 4 groups of 8 bits. Each 8-bit is written as a decimal number ranging from 0 to 255. These decimal numbers are separated by dots. In binary notation, each decimal number represented with binary values, and here we do not use any dots in between. Binary math is based on power of 2. For a given 8-bit data, if we set 1 for each bit at a time from left to right, we get the following values. Here, in the first octet, the leftmost bit is set to 1. Therefore, 2 to the power 7 means the value 128. In the second octet, the second bit from the left-hand side is set as 1. Therefore, 2 to the power 6 equals 64. Similarly, the other values also can be calculated according to the bit pattern. So the first one we get is the leftmost bit and the last one we get is the rightmost bit. So here if we set firstmost bit is 128 and the rightmost bit is 1. This is how we convert binary value into a decimal value. Here the first bit, that means the leftmost bit, is set to 1 and the rightmost bit also set to 1. Therefore, leftmost bit means 128 and the rightmost bit means 1. 128 plus 1 equals 129. Similarly, in the second octet, there are 3 bits set to 1. 2 to the power 0 bit, 2 to the power 1 bit and 2 to the power 3 bit. Therefore, we will have to add number 8, number 2 and 1. Means number 11 is the final value. This is how we convert a decimal value into its binary form. Here you will have to divide the decimal value by 2 and consider about the remainder. In this calculations, the remainder is taken from bottom to top. Therefore, for a given IP address, there are no more than 4 numbers in dotted decimal notation. There are no leading zeros. Number range for the dotted decimal notation is 0 to 255. An IP address cannot have a mix of dotted decimal and binary notations. What we mean by network mask? Network mask is used to separate the network portion of the IP address from the host portion. Simply, we can say number of bits assigned to the network portion is indicated by the network mask. Therefore, if you say a 24-bit mask, that means in your network you have 24 network bits and 8 host bits. If your network mask is 16-bit mask, that means you have 16 network bits and 16 host bits. Here if you add 24 plus 8, that becomes 32 and 16 plus 16, that becomes 32, which means the size of an IPv4 address. This is how we calculate network host and broadcast addresses. In the network address, all the host bits are set to 0. In the broadcast address, all the host bits are set to 1. Here we have 24-bit network mask. Therefore, these 3 octets belong to the network side, and the last 8 bits belong to the host side. Here, if we convert the binary values into a decimal value, we get the address 192.168.32 and 0. Here, the bit mask is represented as 3255 values, and at the end we have 0. That means in the network side we have 3 octets, and for the host side we have 1 octet. For the 1 octet we have here, we have marked 0, and for the 3 octets we have here in the network bits, we have marked as 3255 values. In between network address and the broadcast address, we can have all our hosts. And therefore, for the first host address in this network, we can have 192.168.32.1. Here, if you check the host bit, 1 bit is set there. And for the last host, network portion remains same and the bit values have changed. In this example, we have 16-bit mask. 16-bit means you have 16 bits for your network side and another 16 bits for host bits. And the bit mask can be represented as 255.255.0.0. These 2 zeros are for the host side and these 255 values are for the network side. And here also, network address can be taken by making all the host bits into 0, and the broadcast address is the one we meet when we convert all the zeros in host bits into 1. And in between we have number of hosts. Here, the first host can be taken like this, and the last host can be taken like this. Therefore, for a given network, the network bits remain fixed and the host bits vary. Network address is found when all the host bits are not set, and the broadcast address is found when all the host bits are set. And in between, we can have all other remaining hosts. If you want to determine the number of hosts in a network, this is how we do. Assume there are n number of host bits. Therefore, we can calculate the hosts available in that network using this equation, 2 to the power n minus 2. Therefore, when the number of host bits are 8, we can calculate 2 to the power 8 minus 2. When the number of host bits are 16, we can calculate 2 to the power 16 minus 2. And when the number of host bits are 24, we can calculate 2 to the power 24 minus 2. In each case, we have minus 2. This minus 2 means we remove the addresses which we used for the network and broadcast. For a given network, we have one network address and one broadcast address. And therefore, we always remove those two to obtain the number of hosts in between.